Hello, geometry folks. Today we're going to be talking about circles, not just what we already know about circles, but in addition to that, arc length of a circle, an area of a sector in a circle, and an area of a segment in a circle. So what you're going to need today are your notes, the foldable that you should have gotten in class, a pen or pencil, and a calculator if you think you're going to need it. So somewhere not on your foldable yet, please write down the two things we already know. These are the two circle facts we already know. That area is equal to pi r squared and circumference is equal to 2 pi r. So in the case of a circle, area is talking about the entire shaded 2D portion, right? And I always remember that because when we talk about area, we always want units squared. So it's pi r squared for area. So if you get these two formulas confused, maybe that'll help you. And then for circumference, circumference is just concerned about the perimeter of a circle. So we're just having linear units here. So the 2 is a constant out in front, so 2 pi r, or some people also do pi times diameter because 2r is also diameter. So make sure we have these two formulas written somewhere outside of that foldable in your notes. Sometimes, though, we're not concerned about the whole entire circle, but only a part of it. Like, for example, we only want to know this sector's area, or just this pizza's area, or maybe just the distance of this circle on that kind of a road. So when those things happen, that's where this foldable is going to come into play, and we're going to have some new formulas that we're going to learn in order to figure out how we find a part of a whole, or only part of a circle. With new formulas comes new vocabulary. So in your notes, I'm just concerned with you writing down what's on the left side of this black line. So if you want to draw this picture, that's probably the best way to describe the arc, the sector, and the segment. Those are our three new words today. So an arc is just a length of a circle, but it's not the entire circumference of a circle. It's just from one point to the other on the circle. So we measure an arc in length. Some people say arc length so they understand. A sector of a circle is going to be the entire region, this whole entire thing. So that's concerned with finding area. So finding the sector of a circle is finding the area of just this portion of the circle that's being cut out. And then last but not least, a segment is made of two parts. It's a line that doesn't touch the center, so it's going from one end of the circle to the other without going through the center of the circle. So this is not the diameter. And then it's also the other part of it is a curved part of the circle. So the exterior part and the line connecting the two dots on the circle. And then it's the area inside of those two parts. So again, this is going to be concerned with finding area. If we can't see that, I'll rewrite it here. So make sure we get that picture in our notes somewhere, again, not on your foldable. We're not using the foldable yet. Okay, and then just for other reasons, if you ever see the word major sector or minor sector, this is what it means. Minor means less than half of the circle's sector. Major means more than half of the circle's sector. A minor arc means that in length it's going to be less than half of the circle, and then a major arc is more than half of the circle. So that's what minor and major mean. Think about it in terms of less than half or more than half. So I figured those ones were pretty self-explanatory, but if you want to draw these into your notes as well, please feel free to do so. So we do not need to write this problem down, but this is going to be like kind of the idea of where we're trying to go with this. All these parts of a circle, what we're trying to accomplish in this lesson. So this is an application problem, if you will. If the radius of the minute hand on a clock is 12 centimeters, in centimeters, how far does the tip move between times 11:55 and 12? So assuming that the minute hand reaches all the way to the end of the clock, we're wondering what's the length of this arc from the 11 to the 12 on the circle. So we were told that the radius was 12 centimeters. So the circumference of the entire clock is going to be 2 pi times 12, right? Our radius. So our circumference is 24 pi. We also know from 11 to 12 is 1/12 section of the entire circumference. So the length, I'm just going to use L, is 1/12 times the entire circumference of our circle. And that's going to be 2 pi, or as a decimal, approximately 6.28 centimeters. So that is kind of a generalization of where we're going to be coming up with these formulas. So hopefully that helps maybe to keep a mental picture of what we're trying to do in these next couple slides. All right, so now's the time that we open that foldable under the section arc length. So under that example, we are going to talk about the formula for it. So arc length is the length of a curved portion, right, on the circle, but it's only part of the circumference. So a more generalized formula that people can think of when we're talking arc length is that arc length is equal to the fraction of the part times the circumference, or if you're looking for like an actual formula like we're used to, arc length is equal to the degrees over 360. So the part of that, this part's degrees over 360, because we always have a total of 360 degrees in a circle, times the circumference, which is 2 pi r. So in this specific example, if we set it up using that formula, we would have 70 over 360 times 2 pi times our radius, which is 4. So if we reduce that fraction, we get 7 over 36 times 8 pi. 7 times 8 gives me 56 pi over 36. And for our purposes, we're going to keep that in, we're going to keep our answer in pi, and we're not going to use a decimal. But we could keep reducing the fraction, right? 56 over 36 is going to give me 14 pi over 9 centimeters. And we're talking about length, so we're just going to keep it as centimeters, not centimeters squared or centimeters cubed. So make sure you get all that in the little foldable, with the most important part being that formula. Arc length is equal to degrees over 360 times 2 pi r. All right, so now we're going to talk about sector area, and it's kind of the same idea as length, except now we're talking about the area of the circle. So sector area is equal to the fraction, or the sector, times the entire area of the circle. So as you can about imagine, our formula is going to be degrees over 360 times pi r squared, because we're talking about the area now. So it's pi r squared, so the area formula of a circle. So in our example, our fraction is going to be again 70 over 360 times pi. Our radius is 9, so 9 squared. So that's going to become 70 over 360 is 7/36 times 9 squared is 81 pi. If we take 7 times 81, we get 567 pi all over 36, and that fraction can be reduced to 63 pi over 4. And for our purposes this unit and in this project, we are going to keep our answers in exact form, meaning with pi, no decimals for now. This is our final example. So we're going to be talking about segment area. So segment area is finding the area of the shaded region, which is this region right here. So how we can do that is by taking the area of the sector, which is in blue here, and subtracting the area of this right triangle here. If we break it down into things that we know how to find the area of, we can just do what we call composite area, where we either add or subtract to get the desired area of the weird shape like the segment that we wanted. So let me say that again. Segment area is the area of the sector minus the area of the right triangle, or the area, remember the area of a sector is degrees over 360 times pi r squared, minus area of a triangle, which is 1/2 base times height. So let's plug in what we know. We know that our degrees in this little circle is 90 over 360 because we were given a right triangle, or sorry, a right triangle and a 90-degree angle with that box, times pi, our r was 6 squared, all minus 1/2, and we know our radius is 6 and our other radius is 6, so our base is 6 and our height is 6. So minus 1/2 times 6 times 6. So 90 over 360 is 1/4 pi times 36 minus 1/2 times 36. So we know that 36 divided by 4 or 36 times 1/4 is going to give me 9 pi. And we also know that 1/2 times 36 is 18. So 9 pi minus 18. Remember that we're saying pi is a value of 3.14 and we could keep going, right? So this value, you guys, 9 pi minus 18 is not going to be negative because remember we're taking 9 times 3, which is going to be larger than 18. So for our purposes though, we want to keep this in exact form. So just like when we were adding and subtracting radicals or combining like terms back in Algebra 1, 18 has no pi term on it, so we just have to leave it like it is, 9 pi minus 18. That's all we need for our purposes in this unit and for our specific stuff. So thank you guys for taking good notes, and that's just a little intro to circles, and then the rest of circles and everything we need to know about circles will be taught after our project. So thanks for taking good notes, and I'll see you guys soon.